Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, California Resources Corporation, Bakersfield West Rotary Stroop Family Foundation, Panama Buena Vista Union School District, Bakersfield City School District, Kern High School District, and AC Electric Company, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
And I'm Devin.
And in studio with us we have Luis. And Luis, if somebody needed to get a hold of us, what would they need to do?
For math homework, help call in Bakersfield 636-4357, toll free 1-866-636-6284, email dothemath@kern.org. We're online at dothemathonline.net. And on social media, Facebook, Instagram, Twitter, and YouTube.
All right, nicely done. A lot of different ways to get a hold of us, aren't there? All right. So why don't you let everybody know where you go to school and what grade you're in?
I'm in 4th grade and I go to Loudon.
And you've been at Loudon for a long time, right?
Since kindergarten.
Since kindergarten. So you're pretty used to the place. You think it's all right? It's going pretty well. How's the principal running everything over there?
Good.
Okay, yeah, we won't put you on the spot right there. So, do you like the way school is right now? Are you able to do school like you're pretty good at it?
I'm good at it, but I don't really like it.
Yeah, so well, that's good that you're good at it. You kind of got adapted to it and you kind of figured it out and stuff like that, but you don't like it. So what would be the one thing you would like to change about school?
I would change for us to go back to school.
You go back to school. Now, if they said you can go back to school, but you have to wear a mask all day, would you still do it? You don't want to go back then?
No, I wouldn't wear a mask all day.
You don't like wearing the mask all day? All right, yeah. I mean, you can kind of be like an annoyance a little bit.
I'll tell you what you can make any face that you want though. Like sometimes you're in school and you want to make a face at like a classmate or a teacher and like you get in trouble for it. Now, you can do whatever you want. Nobody's going to say anything.
They can read it in your eyes though, I bet you, huh?
Right.
All right. So, you've been working on some multiplication lately in class, right?
Yes.
All right. Why don't you know what, we're going to take a quick real minute here and just do one quick multiplication problem with you, all right? Head on over to the board, and you can select any two-digit number you want, all right? So you select the first number, the two-digit number.
So like 22 times 22?
Well, you just pick the first number. I'll pick the second number. Oh, yeah, just take your hand off the board. There you go. So you want to go 22? All right, I will go 27. So if you could explain to Devin how you're going to multiply that, and then afterwards, we'll look at another way, Devin, to multiply later. All right?
Got it.
So I'm going to do 2 times 7, 14, like that. So 4 times 7 equals 28. So plus 1, 29.
Now, quick pause right there. You said that when you did the ones column, that 2 times 7 is 14. And then you had 2 times 7 again. You had the 20 times 7. And you said that that was 28? Because the first time you did it, it was 14. So if 2 times 7 is 14, what is 2 times 7?
Oh, 2 times 7 is 14.
Right, so we want to make sure that we keep those values, because if you add 14 and 14 together, yeah, that gets you 28, but we're not necessarily adding the products across the board yet. So we're adding that, and yeah, you got that 5 in there too, right? Because we have the 14, but we have that 1 that we brought over, right? So that would be 14 plus 1.
So 15?
15, right. Okay, so we've got 22 times 7. Now there's another piece, right? We have in that 27, the 2, which represents 2 tens. So now we're going to multiply the 22 times the 2 tens.
So do 22 times 10?
You could do it over there. However you normally work in multiplying these two together. So you did the first part. Well, that's interesting. What's nice is when you multiply by 10, you always know that that first digit's going to be a 0. And then you can go straight to the tens place, right? So now you can start working with that 1. So when we multiply, we're doing 2 times 1, right? So 2 times 1 equals?
2.
Right, okay. We want to make sure that we're not getting addition and multiplication mixed in together. Now we don't have to carry anything over since it's a single digit product. Then we go to the next 2, right? 2 times 1 again. Well, it's a good thing we just did that one, right? So another 2 times 1. Well, just right over here on the side. Hold up. So like right over here, right? Right over there is where we do that 2 times 1. So 2 times 1 equals? Right. So we know that 22 times 10 is 220. But really what we're doing is we're multiplying it by 20, right? So we can just double this, right? We know that 220 is 10, and another 220 would be 440. Basically what's going on is it's really tricky to kind of keep a lot of this organized, right? So let me kind of walk you through another way that we might be able to kind of work with this. And you tell me if you've seen this before. And some of our classmates that are watching may have done so.
You're going to do the area thing?
Should we hold off on that?
We're going to hold on that.
Okay.
Because what I'd like you to do is just do the 440 right now.
Okay.
And add it to what he had before.
So we'll put that right there for you. And then you're going to go ahead and add those two together. Is that correct?
440 plus
the 154 that we have up there. Yes.
Now you can erase that other stuff under there if you want. Get rid of that stuff.
So we're saying here that 22 times 27 equals 594. Now, one of the things that kind of got in the way of working with a lot of this, especially going down in that straight line, was our organization, right? Like we started doing some over here, but then we had to continue working over here. We ended up writing over our own writing. So, when I was in 4th grade, I was kind of very similar in the sense that I wrote very close together. And so organizing things in straight lines sometimes was very difficult. So you tell me if you have seen this method before, where you have a large kind of square space that you work with to multiply. The area model?
That's what we're going to do next, but
Okay.
we're going to do that right after we take a look at today's Math in the News.
Is that teaser?
All right, today's Math in the News, this came hot off the presses yesterday. Now, Luis, do you collect anything? Like baseball cards or anything like that?
Oh yeah, I collect Pokemon cards and
Pokemon
baseball.
cards. There you go. All right. So a lot of people collect things, and Devin, we're around the same age. I remember a lot of kids. We used to collect coins.
Yeah. Now, well, hold on. What kind of coins? Are we talking money coins or the coins that like you would slam onto the cardboard things and like you pop up and collect the pogs, right? That was a thing.
Real
for
money.
me. Okay, then
Coins.
I mean, I like money. I'll always collect money.
There you
That
go.
doesn't go away.
Now, one thing is that some people have a tremendous amount of a certain coin around. How many pennies do you think you have in your house right now?
Oh gosh, I'd have to smash the kids' piggy banks, dig through the couch. I'd say about $5 worth.
All right, so
Yeah.
500 pennies.
Right.
All right. Luis, how many pennies do you think you could find around your house right now?
More than
More than
600.
500?
Oh really? Okay.
How many?
Now I didn't know we were having a competition here about who had more wealth, but I guess that's happening, everybody.
How many pennies do you got?
More than 600, I think.
More than 600. All right, there you go. More
Challenge
than 600
accepted,
pennies.
Luis.
All right. Well, we're going to need all of you guys' pennies all together. So, here's the story that came out yesterday. Lane Kiffin, a football coach in the Southeastern Conference, threatens to pay a $25,000 fine with pennies. Struggles with math. Obviously, I had to take a look at this deeper, find out what was going on. So, what he did is he got fined, and he wanted to figure out, all right, how can I get back at these guys? So it was a couple of years ago. You guys might remember this, where a guy paid $3,000 in a fine, or actually it was a bill, I think, for his bill, and it was $3,000, so he wanted to pay it in pennies. And that's what it was, and that obviously made big news, all right? So Lane Kiffin says, where can I find 25,000 pennies? Because he's being fined $25,000. Now, Luis, if you're being fined $25,000, can you pay it with 25,000 cents? No, you can't do that, right? Everybody knows this, okay? But obviously, Lane had a little bit of a problem with this. So he says, where can I find the 25,000 pennies? And somebody else goes, oh, 250,000 pennies, all right? He says, that's better. Well, that's not it either, all right? So we continue with the story, and he says, where can I find 25,000 pennies? And now it's 2.5 million pennies. There you go. Now the math looks right on that one. So he was saying, just want to see if the SEC is keeping track of it. So there's our news story. And now let's take a look at the math behind all of this, all right? So we can see if we had 25 pennies, that would be equivalent to 25 cents. Do you agree with that, Luis? If I had 25 pennies, that's the same as 25 cents, right?
Oh, yes.
All right, there we go. So if we had 250 pennies, that would be equivalent to $2.50. So now we're just moving the decimal and inserting some zeros. So we can see if he has a $25,000 fine, he's going to need 2,500,000 pennies. So you, Luis, you'd be able to pay the $2.50 fine, right, wouldn't you? Because you've got 250 pennies. Devin could pay that also. He could pay it twice. You guys could pay it twice, right? How long do you think it would take you to get 2 million pennies?
A year.
This man says
that's pretty
a
good.
year.
Get it a year. You know what? You get $25,000 pennies in a year. I'm going to come check you out, see what you're doing to get that. That is today's Math in the News. So there's a lot of people out there like to see if they can get around somehow and be a wise guy a little bit and say, you know what, I'll pay your fine. I'll pay it in pennies.
The math
Go
I
ahead and
liked
start
on that.
counting them all.
The math I liked on that was the number of people that liked the first tweet where he got it wrong, and watch that number go down the closer he gets to being more and more accurate.
Right.
That might just be Southern college football culture.
And that, you know what, because there are a lot of people that are going to get on him because of this right now. So anyway, so you guys came up with 594 when you multiplied 22 times 27. So now what Devin is going to do with you is you guys are going to work on a different multiplication model where you're going to multiply those two numbers in a different kind of a way, all right? So Luis, you and Devin go to it.
So let's take a look. Fresh page. I just want to remember where we started off here. We just finished off showing that 22 times 27 was equal to 594. I want to put that up there so we remember that. Now, organizing some of those in the place values going straight down can be really tricky, especially if you're writing on a different upright surface like a smartboard or even like on paper, depending on your grip on it. So you said that you were familiar with the area model. And I want to see if we could work through what that would look like and as far as how we'd work differently with it. So if this was an area model, let's say I was going to write a rectangular array here. So I'm going to make some cross sections here. Our numbers were 22 times 27. Let's see if I'm going to put 22 up here and maybe 27 to the side. How would I make sense of 22 to work with it up here? Go ahead, yeah, grab yours. If you want to write on that, go ahead. I just wanted to set the table for you here.
Put 22 down here and 27 over here.
Okay. So how would I break those up to work with them more easily? So instead of 22, what am I going to put up here so I can multiply with them?
22 times 2.
Well, we don't want to multiply 22 times 2 quite yet. What I want to say is, can we break 22 up into easier parts to play with? How would I break 22 up?
You could put 20 and 20.
Well, does 20 plus 20 equal 22?
No.
How do I add to get to 22? Using friendly numbers. We can keep the 20, but what else would I need to add to that to get to 22? 20 plus what equals 22?
2.
Yeah. Now, on that same boat, what could I do with 27 here?
You could put 20 over there and 7 right there.
Okay, let's do that. So, the way that the area model works is we know we can find the area of a rectangle by multiplying the length times the width. And what's great about this is that we can do this in any order we want. So this is going to be 20 times 20, this is going to be 20 times 2, this is going to be 20 times 7, and this is going to be 2 times 7, and then when we have all that, we can just add them together however we want. So let's do whichever one we want first. Which of these would you like to do first?
20 plus 2.
Well, when we get that, we get 22, right?
Yeah.
And that's our original number that we're adding up to. But we're not really working with 22 right now. And we're not really working with 27 right now.
20.
So you want to start off by doing 20 times 20? Okay, what would 20 times 20 equal?
400.
400. And you did that, what's interesting is that you did that mentally. You saw that there were 2 zeros, and then you multiplied the 2 and the 2 together. So yeah, that's 400. This entire big block is 400. I'm going to write that over here, just so I remember that, okay? Which of these rectangles would you like to do next? Okay, let's do 20 times 2. That's another straightforward one. What's 20 times 2?
400. Wait. 40.
40, there you go. And I appreciate how you self-corrected there, because a lot of people will just like move on with the first answer they get, but you really thought that out and reflected. You heard yourself say 400 and you said, oh, that doesn't sound right. Let me reconsider that. And that's a really powerful skill to have. So I'm going to pop a 40 right over there. Okay, which of these rectangles can we do next? 20 times 7 or 2 times 7?
2 times 7.
Let's do 2 times 7. What is 2 times 7?
14.
14. Wonderful. I'm going to throw that right over here. Now we have one more left here, 20 times 7. But, I mean, we can use some of the same idea behind 400 that we can use for 20 times 7. So what would you get for 20 times 7? In fact, since we did 2 times 7, that should make this a little bit easier, right? So what would be 20 times 7?
144.
144. If we have that 0, what has to be at the end?
140.
140, nailed it. All right. So what's nice about the area model is that you can add this up however you want. You can add these 2 together, you can add these 2 together, and then add those 2, or you can add all this together at once. How would you like to do it?
400
all
plus
this right
40.
here down the line? Great.
No.
Oh, no, you don't want to do that? Which one do you want to do? These 2?
Yeah.
Okay, you want to go across here. 400 plus 40 equals?
440.
440. And then these 2, 140 plus 14 equals?
154.
And now we can add 440 and 154. Now I want you to notice at the end you did 440 plus 154 equals 594. Not only is that the same thing we got the first time, but when you multiplied using the standard algorithm, you did so by doing 154 plus 440, because you did 22 times 7 first, and then you did 22 times 20 second. So it's the same multiplication, it's the same addition, but just in a different order to get to that same spot, 594.
There you go. Nicely done, guys. Some great work right there. So, Luis, what I'd like you to do is erase the board. We're going to go ahead and start with a new problem.
I got that for you, sir. There you go.
All right. So, Luis, select another 2-digit number. All right, 32, and I'm just going to reverse it, 23 for the second number. Now, I would like you to explain to Devin, and you can do it whichever way you like. Okay, you can do it like that, or you can do the area model that you guys just did. But I would like you to explain to Devin how you're doing it.
I'm going to do 2 times 3 equals 5, and then 3 times 2 equals 5, so it's going to equal 55.
I just want to go back there quickly, okay? Let's start off with the 2 times 3,
Wait,
okay? If we're multiplying 2
6.
groups of 3, we're going to get 6, all right? So let me just go ahead and start and erase all that, right? Now remember, when we multiply through the standard algorithm, we start off with this 1s times 1, and then we do a 10s times the same one. So we're not just going straight down the line like we would with addition or subtraction. We have to do all of this times this value, then all of this times this value. So we have 2 times 3, but now we're doing 3 times 3. So what does 3 times 3 equal?
9.
Go ahead and throw that 9 right there. Now we're going to go ahead. We're done doing 32 times 3. Now we're going to do 32. And a lot of people think of this as 2. But really, since it's in the tens place, it's 20. So we're doing 32 times 20. We already know that anything that you multiply
It's
that ends in a 0 is a 0 here. So now, yeah, you're going to go over here. So we have 2 times 2.
64.
Oh, yeah, go ahead and throw that down. Great, you did 32 times 2 just right off the head. Is that going to go right next to our original part, or do we have to put it below here so we keep the place values aligned? Okay, so I'm going to go ahead and I'm going to bring all this over here so it's lined up nicely, okay? So we have 96 from 32 times 3. We have 640 from 32 times 20. Now, we're going to combine those pieces together. What happens when you add both of those pieces? He's got the adding down on point. To get us to 32 times 23, which equals?
736.
736.
You know, I like how when he does by the tens digit, he just does that in his head so fast, right? You got the 64 without a problem, right? It's just that first digit that I think is throwing you off a little bit, where it was 2 times 3, because I think what you were looking at is adding, and that's how you got the 5, right? So you want to do one more real quick? All right, erase that real quick.
There we go. You got it. Okay. He knows his way around a smartboard.
All right, let's go 17. And what would you like the next number to be?
Is that
20?
20? All right.
All right, go to it.
Have at it. He worked quickly to do 7 times 0 to get that 0 down right away. Now he's doing 7 times 2, really 7 times 20 with that 2 in the tens place. And he knows that 7 times 2 equals
14.
14. So
140.
140 for that 20 times 7. Excellent.
Do I put it down here?
You can put that right up there by the multiplication bar, right there as you normally would. So 140. Yep. And then we can get rid of that 0 on the side there so that we're not confused. We don't want to say that this is 1,400. The 140 works great. So we did 20 times 7. Now we're going to do this 20 times 10 over here.
20 times 10 equals 40. Wait. 20 times.
And you don't have to do it in your head if you need to work it off on the side. Or what a lot of people do with this is they know that this is going to be a 0. So they put a 0 down there preemptively. Some people like to put an X there just to hold the place, but when you do that, you really lose sight of what that X really means. So that's why the 0 is really helpful. So now that we have the 0 from the 10 already over here, we can just treat this as 20 times 110, or 20 times 1 in the tens column.
And that equals
So,
40.
Well, let's work one digit at a time here. 1 times 0.
0.
All right. And then this is 2 times 1.
2.
So 20 times 1 is 20. 20 times 10
Is 200.
is 200. So we have our 20 times 7 equals 140, and we have our 20 times 10 equals 200. So 20 times 7 plus 20 times 10 equals
340.
340.
There you go. Nicely done. For your great effort today, you get yourself a meal courtesy of our friends at Chick-fil-A. So nicely done on that, Luis. We'll be back with more right after this.
The wing itself is just an amazing tool, and this is what creates the lift to be able to lift this airplane off the ground. Now at takeoff, this airplane weighs 20,200 pounds, okay? That's how much it weighs at gross weight. And all the performance numbers that have been developed for this airplane are based on weights. So when you talk about numbers, you talk about things, everything we do is based on numbers and performance. So this wing is what creates the lift to be able to pull that 20,000 pounds up. But once we're flying, you got to ask yourself, okay, how do we control the airplane? Well, if we want to go right to left, okay, laterally like this, we control it with what's called the ailerons right here. See these? And you look at the aileron and you watch it go up and you say, okay, what does that do? Well, remember, this air is coming across this wing at 200 or 300 or 400 miles an hour. As soon as it hits this, what's this wing going to do?
It's going to be deflated. So what you've got is you've got the ailerons affecting whether or not it's going up or down.
That's right, this wing. So this is going to do what? It's going to lower this wing, right? Now, if we were going to look at the other aileron, what do you think it's doing? The exact opposite. What's going to happen is this wing's going to lower, the other one's raising the wing, so we're going to make a right turn. We want to make a left turn, then this wing is going to go up, and the other wing's going to go down. So these are the ailerons. Then we have the flaps. And what flaps do is at lower speeds, the wing becomes less effective. Okay? And so what we do is we increase the wing area by bringing these flaps out and down. And for any of the kids that have flown on an airliner,
if they've looked out the side, they've seen that happen.
Look outside the window and watch the flaps on the back of the wing. And those wings are sloped more for higher speeds, but they also have slats, which are called slats in the front to increase lift also. So the front of the wing goes down, the back of the wing comes back, and that's all designed to be able to let the airplane fly at slower speeds. This is the rudder of the airplane right here. You can see how it moves, okay? And that's controlled by the pilot's feet. We control the rudder by the feet inside the cockpit. Now, when we're on the ground, those controls, foot pedals, are controlling nose steering. But as we take off and all of a sudden we accelerate and there's enough airspeed over the rudder, then it transfers, and now this control here, yaw, now is controlled by the rudder.
Got it.
Okay? Now, but the only way we can get off the ground is by putting the airplane nose up, right? And that happens right here with the elevators. And what the elevators do is they both work together and they go up. And when the elevators go up, they push down, which raises the nose, and the airplane climbs like that.
So the elevators control the pitch of the plane,
That's exactly right.
whether you want to go up or down.
And that's a good point. There's 3 axes of flying. You've got pitch, yaw, and roll. And those 3 things put together makes every airplane ever built fly. Right now, what we're doing is an inspection right now, so you can actually see the sophistication of the engine. This is the fuel control unit. This is what monitors and changes fuel flow that goes into the engine. A very sophisticated computer tool that analyzes basically the amount of fuel that goes into the engine, because that has to change for altitude, for temperature, and for all the other things that are going on while the airplane is flying. This is a Pratt & Whitney 545W. It produces 4,100 pounds of thrust. And at takeoff, this engine's burning right around 200 gallons per hour, and at cruise, it's down to about 90 gallons an hour.
How much fuel can this plane hold?
1,000 gallons.
1,000 gallons.
Right. And it has the range to fly almost 2,000 statute miles. As this airplane flies through the air at 400 to 430 knots speed, tremendous amount of static electricity, especially in clouds and in rain and snow.
Well, certainly an incredible amount of science and math with aviation. We do have phone tutors available until 5:30. Phone numbers are at the bottom of your screen periodically throughout the program. Time now for today's Museum Moment. All right, and today we've got Dave Hanley in from the Buena Vista Museum. How are you today, Dave?
I'm doing real good, thank you. How about yourself?
Excellent. Nice to have you back and working with Venn diagrams today, right?
Right, Venn diagrams. When I was in college, I realized that the Venn diagrams that we did in math when I was in elementary grades, we did Venn diagrams. I realized that those were the foundation for Fortran. I took the computer class Fortran, and I realized that the vernacular that they use for Fortran language is very much the vernacular that you use for Venn diagrams. And so it was made it natural for me to be able to understand Fortran computer language.
All right, well, you've got Luis to help you out. Go to it.
All right, Luis, thank you. Thank you for being here, Dave Hanley. Let's do a shake. I know this, it's all right. We'll alcohol our hands afterwards, okay? All right. I got some objects on the table here, and I thought they'd be good objects for us to be able to use to compare Venn diagrams, okay? Or to use Venn diagrams. There are different kinds of Venn diagrams, and so you'd said to me earlier that you haven't done Venn diagrams in school yet or in any of your classes yet. You have or haven't? No, okay. That's what I thought you said. Okay. So on this table, we've got a world that is all objects. All right, all objects on that table, right? Okay. Now, all of these objects have shapes, right? Okay. So we can take another circle and we can say shapes. So what are shapes? Don't worry about my spelling. Shapes, okay. So what we can say is all the objects have shapes, right? This is triangular, square, cuboidal, spherical, right? They all have shapes. Okay. And so these are both all shapes. Well, all objects. Let me do it this way. All objects. Oh, let's do it in blue. How's that? Okay, we'll match it up. How's that? All objects have shapes. Okay? And what we call that, all A equals B. And we call that a universal inclusive. Okay? In all of these objects, are any of these objects blobs?
Yes. Wait, no.
No. So no objects. So out here we would have a thing called blobs. Okay? And so that means that no objects are blobs. Right? Okay. So that means that these are called mutually exclusive. Right? None of the blobs are in here. Okay. Those are universals. Now we can talk about partials. Okay, so some of the objects, okay, they all have shapes. Some of the objects are,
Circle.
okay, so we're going to call some of them spheres. Okay, some of the objects are spheres, but not all of them, are they? What other shapes do you see in there?
Square.
Okay, so I see some cubes, right? Yeah, I see some cubes. Some of the objects are cubes. So those are partial inclusive. Okay, are all of the cubes square?
No.
Okay, so what are some of them are? Okay, I'd call this. Okay, is this a square?
Yes.
It's a square, but it's not a perfect square, right? It's not a perfect cube. It's okay. Is this one a cube?
No.
Okay, so some of the blocks, we'll call these blocks. Let's move these all over. These are all blocks. Okay, so all of the blocks, are all of the blocks cubes?
No.
Okay, so we're going to do another circle, okay? So we've got all of the blocks. That's one, okay. And those are all the blocks. Are all of the objects blocks?
No.
Okay, so some of the objects are blocks. Okay, so of the objects, these are the objects. What are some of the other objects?
Spheres.
Spheres, okay, there we go. So we got spheres. Are any of the spheres blocks?
No.
Okay, all right. So these are partial inclusives, right? Okay, so sum A or sum S equals O. Sum. Sum O equals B. No S equals B. All right? And so we can do all kinds of logics with that. And of course, these, you see my spheres here? Did you notice that I've drilled holes in them? I left them in this. They'd probably be more fun for us if we'd pulled them out of this crate and all this, but I had to keep them in this package so it's easy to drill holes in them. Now, if we looked at these, do all of the spheres have holes?
No.
Which ones don't have holes?
The little ones. Wait.
Oh, I did get a hole in those. Oh, I did get a hole in that one, too. What about these?
Oh.
These look the same, aren't they? Feel them. Are they the same?
No, this one's lighter.
What would you? Okay, what makes that one lighter?
It doesn't feel like there's nothing in there, and it has green on it.
There you go. Okay, good. Yeah. Okay. So all the spheres don't have holes. Some of the spheres have dents, right? But not all the spheres have. Okay. The reason I left them in there is I make toys with high bounce balls.
And you guys have got about 2 more minutes, Dave.
Can you make that do around the world? Can you walk the dog? Okay, there you go. You're walking the dog. You're walking the dog. Okay. Can you do hourglass? Oh, it's tangled. Let's untangle it. Okay, good. Here we go. Okay. Do hourglass. Okay, back to walk the dog. Do walk the dog. You know, you can do that. There you go. And this can work for astronomy. You can use this and you can do the axis of rotation for a planet and a moon. And so this is called astrojacks. Okay, next time we meet. Oh, see, there we go. I'm trying to do hourglass now. So I do walk the dog when I want to do hourglass. I do hourglass when I want to do walk the dog. I'm not very good at it. I bet you're going to be better at that than I am. Okay?
Wait, what do I do?
You get to practice with it anytime you want. It's yours. Astrojacks.
There you go. Nicely done. Thank you, Dave. And a nice explanation and illustration with the objects on Venn diagrams today. And that is today's museum moment.
Thank you.
You bet. Thanks, Lisa.
All right. We do have phone tutors available until 5:30. We'll be back with more right after this.
Finally, we get to go out and have a hike. Now, I'm a naturalist and ecologist. When we look at the world around us, we can categorize things that we see as biotic or abiotic. Now, me standing here right now, I see a bunch of abiotic rocks and sand that make up this trail. Krill's gonna talk a little bit about trails.
All right, friends, just like Kestrel mentioned, a lot of the trail is made up of abiotic factors like rocks and sand. So on this trail, while we are walking, I just want you to be mindful of the trail itself and notice that all of the surfaces are not flat like a sidewalk. So just be aware that wherever you're putting your foot isn't somewhere you are going to twist your ankle or fall. And if you're lucky enough, you'll get to hike by the ocean.
I hope someday you get to take a hike by the ocean. It's one of my favorite places to hike. But when I think about abiotic factors we have to be aware of, I think a lot about water. And when we're by the ocean, we say, turn your back and the ocean might attack. So watch out.
So students, here in California, we get a lot of hot and sunny days and even sometimes drought. But while you're hiking, you are always going to take water and you're going to hydrate multiple times throughout the day. You are always going to apply sunscreen, again, multiple times throughout the day. And it's always good to have a hat, and you're always going to want it facing forward. That way it can protect your face, and even I sometimes have a hard time with that. Next, we are going to be talking about biotic factors that you will come in contact with on your hike.
I love plants. There's some plants you have to watch out for when you're on a hike. Right next to me, I have blackberry, an amazing plant that protects itself by being covered with thorns on the leaves and the stem. Right next to it, poison oak, leaves of 3, let it be, it's shiny. And those oils, if you touch them, they'll give you a nasty rash. Actually, I should probably stay on the trail.
All right, students, so right now we are in oak woodland, and if you just look around real quick, you'll notice this is a perfect spot to climb trees or just explore around the trees. So while you're exploring, you just want to look at a couple things. One, the leaves on the tree to make sure that they're healthy, make sure that no branch is going to fall on you. Another is the base of the tree to make sure it doesn't have any big cracks in the bark that might signify that the tree might be dying.
We're back on the trail. Now we're looking for critters, different types of biotic organisms. Now there's some critters you don't want on you, like ticks. Ticks are spider relatives, little arachnids that want to suck your blood by getting to your skin. You can keep them off of you by tucking your pants into your socks and tucking your shirt in. As you hike, check yourself. Do a tick check from time to time to make sure you don't have any little tick hitchhikers on you. When I'm hiking, I'm also on the lookout for reptiles like lizards and snakes. If you get lucky, you might see one. But for safety's sake, just keep your distance. If you're walking in the middle and you're aware of your surroundings, look out for reptiles. Look at them, but don't get too close.
Lastly, if you're lucky, you might see some larger animals on the trail or anywhere really in California. One of the common animals that you might see is a coyote. Now, if you see a coyote, one of the things you'll notice is the color of their fur and how that helps them blend into different environments. And you might also notice that they're going to be running away from you, and that's because they really don't want anything to do with humans. Hey students, some of you guys might be studying extreme weather like tornadoes and hurricanes. We don't have any of that here in California, but we do have heavy rain. So it's super important that you bring a poncho.
Always a lot of things going on with Camp Keep. And they're actually doing Camp Keep classes right now virtually, but the 6th graders are able to experience a little bit about Camp Keep right now. We do have phone tutors available until 5:30 this afternoon. In studio with us, Luis, a 4th grade student from Loudon, been at Loudon since kindergarten. And if you could change anything about school, you would like to have everybody back at school. When do you think that will happen? Do you have an idea? Like, if you had to guess, when do you think it might happen?
Next year.
Next year? All right, so we've got a long way to go then, huh? All right, well, you know what? We're still going to work on some math. You ready? All right, let's take a look at the problem right now. We're going to do a little bit of measurement. So we have 5 sections of pipe. Okay, the first one is 8 feet 6 inches. The next one is 6 feet 7 inches, 10 feet 4, 9 feet 2, and 4 feet 4. So we want to know the total length. Now, if we want to know the total length of all of these, Luis, what do you think we're going to do to them?
We're going to add.
We're going to add them all up, right? All right. So if you and Devin want to go ahead and you can start writing these up there. So the first one is 8 feet 6 inches.
Now, you might see these marks in relations to feet, and it's really helpful for shorthand in case you don't want to write those terms. So you might see 8 feet 6 inches written like this sometimes. Do you prefer using those marks or the actual words?
The actual words.
Let's do that. And you know what? That's really helpful because people use that as almost like a place value, like they would use 10s or 1s. So we'll write 8 feet. Let's write 8 feet 6 inches. Okay.
Luis, do me a favor and clean up his 8 for me, will you?
Look, my
Just
handwriting's in
erase that
second
8.
grade.
Erase
all right?
his 8, Luis. And
I'm
get a
not
better
proud
one
to
up there.
admit this. In second grade, I cheated on a handwriting test at St. Joseph St. Thomas.
Oh, come
in
on. You
Staten
weren't
Island.
using typewriters?
No, no. You want to know how I cheated on a handwriting test?
You turned in somebody else's.
I used a ruler.
Yeah.
I used a ruler. Kids, don't take handwriting tests. They don't serve any purpose right now. You should be using typewriters. Voice typing, that's the way to go. Thank you for that 8. That looks way better. All right, what's our next one, Luis?
6 feet 7 inches.
All right, do you want to write 6 foot 7 inches for me? Since apparently, like, I am the inferior writer of this tandem. I'm not mad. I'm not jealous. I just accept what I am. All right, our next one.
10 feet 4 inches.
10 feet 4 inches, okay? And what I really appreciate is the fact that you're keeping everything kind of in line to keep organized. All right.
The next one we have is 9 feet 2 inches.
9 feet 2 inches.
And our last one is 4 feet 4 inches.
And I just want to clarify, we're not spelling feet with 2 T's. That's a plus symbol. He's actually representing the total lengths as the sum of feet and inches. So he's essentially saying that 6 feet 7 inches is 6 feet plus 7 inches. And that is absolutely on point. That was 4 feet and 4 inches.
Right, so
Yes.
4 foot 4.
So,
And then, Luis, before you guys get started, on your 4 feet, maybe just erase that 4, make it a little clearer so that
Right.
everybody at home knows that that's a 4. Thank you.
all right, so if we're going to combine all these together, what would be your strategy? What would be your approach? Let's talk this out. How are we going to solve this? Before we start writing anything, let's talk about it.
You could do it.
Before we start writing anything, and he goes right to the pen, right? Let's talk about this, right? It's good to have a plan before we go. How would you combine all of these lengths together?
8 plus 6, 6 plus 7, 10 plus 4, 9 plus 2, and 4 plus 4.
Now, that would help if they were the same units. Let me ask you this. If you had 4 apples,
Wait, 6 plus 7 plus 4 plus
there you go. I think you saw the difference there. You're going to add all, and you're going to combine all of the inches first. And then you're going to combine all the feet. So why don't you go ahead, and you can decide what you're going to combine first, feet or inches. All right. So you're going to combine all of the inches first.
All right, well, I'm going to hold on you guys for just a minute. Luis, we're going to put another microphone on you real quick because we have more people that would like to hear what you're doing, and we want to make sure they can all hear you. All right, so go ahead and you can keep on going.
Now, as you combine those, you can start off in any order. Some people like to do top to bottom, and some people like to find groups of 10. We're going to see how Luis does this. Oh, so he works from the top and the bottom and then adds everything towards the center. So he added 6 plus 7 to get to 13. He sees that 4 plus 4 is 2 to get to 8, and then he's got that 2 in the middle. So now he's going to add 13 plus 8 plus 2. And he's going to add those in a straight line. Since it's 3 numbers, it's easier to manage. So he ends up with 23. So what that means is we have 23 inches.
I put 20.
Is that 20? So we have 8 plus 2 is 10, right? And then the 3. Now that 8 plus 2 is 10, but remember we're adding that 3 to it as well. So 10 plus 3.
Oh.
Yep, there you go. It's that 13. So it ends up being 23. All right? So we have 23 inches over here. All right? I'm just going to add the sum up top, if that's all right. 23 inches. So we have 23 inches when we combine all of these together here. Now we have to combine all of the feet together. All right?
Can I erase all this?
Yeah, please, go ahead. It's one of the nice parts about recording what we've already had on the side. And then we want to make sure we get the 6 as well. So we have 8, 10, 9, 4. We still have that 6 feet as well. So now we can bring these together. Last time he applied the strategy of adding the top and bottom numbers together. Let's see if he goes towards the same approach, towards the middle. So that's interesting. So he was able to do everything. Did you kind of find groups of the 10 and then add that to the groups of non-10s? So you had 6 plus 4 is 10, and then you had a 0. 9 and 8 is 17. So you had 10 plus 10. I'm sorry, you had
10 plus 9.
10 plus 9. Okay. Now does that create? No, so when you add everything together, you get 27.
I did 9 plus 8, and I did 6 plus 4, and then
you didn't have to worry about that 0. So that got you to 27. Brought the 2 over, and then you just had 2 plus 1. So 37. So that means 37 feet. Great. So we have 37 feet and 23 inches. Now, that does represent the total length. However, it's very difficult if you ever go to a hardware store to ask for 37 feet and 23 inches. That's kind of another measurement that's unnecessary. Now, if we remember how many inches are in 1 foot, and I have that up here as reference, 12 inches in 1 foot, we can do something with this 23 inches. What do you think we can take from this 23 inches?
Minus 12.
Yeah, we'll bring 12. We're not taking it away necessarily. We're just moving it over. Where are we moving it to?
To
feet, yeah. So 12 inches is going to equal 1 foot. So if we take 12 from 23, what are we left with?
We're left with 25.
Well, if we subtract them, right? Because we're taking 12 inches away from this, and we're shifting it over as an additional foot here. So 23 inches minus the 12 inches.
Equals 11.
11 inches. So we have 11 inches left, and we're taking that 12, and that equals 1 foot, bringing it over here, and we're adding 1 foot to 37 feet. So how many feet do we have altogether?
38 feet and 11 inches.
38 feet and 11 inches of pipe.
There you go. Nicely done.
Go.
Great work right there. A lot of work, huh? All right. Erase the whole board. I've got a great problem for you right now.
All right.
So, before you were working on 2-digit times two digits, correct? We're going to do something a little different now. 112. So put up 112. Yeah, 112. There you go. 112.
112.
So 1. There you go. All right. Times. You can think of any single 1 digit, not 2 this time, any 1. There you go. All right. Explain to Devin how to multiply that out.
You could just 3 times 2 equals 6. 3 times 1 equals 3, and then 3 times 1 equals 3 again.
Very selective with how you went with that single digit. Yeah, made the work real easy, nothing to carry over, very straightforward.
So now what I'd like you to do is we're going to move you on to the next step, all right? Next to it, put 112.
Here, I'll move this over for you if it helps out here. There we go.
Okay, so we're going to go 112 again. So go ahead and write it up there again. Times 0.3.
0.3.
So put your 3, and then put a decimal point before it. There you go. Now, I would like you and Devin to work on that. And you've got 2 minutes.
So what's interesting here is that you have the same digits to work with, right? So do we have to start from scratch to find out what 112 times 3 is? Or do we already know?
We already know.
Go ahead and bring that down. The whole thing, right? Because we know what the whole thing is if we were treating this like 112 times 3. This is the piece that's going to grab our attention, this decimal point. What's the difference between 3 and 0.3?
You stop.
There's a stop there. How would you say that value? How would you say 0.3?
Just 3.
Well, then why don't we just...
times.
Right, so we write that as, we think of that as 3/10. Now, anytime we multiply with a decimal, we take how many total values are behind the decimal, and we're going to shift it over by 1 decimal place. Kind of like this. If you had 112 times 30, what we essentially did was we shifted our decimal value when we multiplied 3 times 10. We brought it over here, and that ends up getting us 3,360. So since we brought the decimal over here, we brought the decimal over 1 as well. So here what we did was we brought the decimal over this way. And this is really 336.0. So if we brought this decimal over here for 0.3, where do we bring this decimal in our value? Right there. So 112 times 3/10 equals...
300.
Well, that's not 300. Now
33.6.
33.6.
There you go. Nicely done. So see, now when you get to decimals in your classroom, you're like, oh, I remember doing that with Devin on Do the Math that one day, right? All right, come on over here, Luis, real quick. So I've got 2 questions for you. Did you learn a little bit something today? Good. And the best and the most important question, did you have fun today?
Yes.
Good. That's what I wanted to hear. All right. Hey, you know what? We do have phone tutors available until 5:30, as we do most Tuesdays and Wednesdays throughout the regular school year. Phone numbers are at the bottom of the screen. And until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, California Resources Corporation, Bakersfield West Rotary Stroop Family Foundation, Panama Buena Vista Union School District, Bakersfield City School District, Kern High School District, and AC Electric Company, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.